here's another word problem that can be solved with the quadratic formula. Okay, so this question says a rectangle has a perimeter of 70 meters and an area of 264 meters squared. Find the length and width of the rectangle. So recall that the perimeter, which in this case is 70, is going to be 2 times the length plus 2 times the width. And the area, which in this case is 264 meters squared, is going to be length times width. So for this kind of problem, we need to express one variable in terms of another variable so that we can get the variables to cancel. In this case, I'm going to express length in terms of width. So I'm going to do that by dividing by W here. So now I have length in terms of width. The width will be in the measurement of meters. So that will work out in terms of the units in the end. I am going to disregard the units for working through this problem because I think it does clutter things up and make it a little bit confusing. So I'm just going to say the length is 264 divided by the width. Now that we have the length expressed in terms of the width, we can replace the length in our perimeter equation with width expressed in terms of length. Sorry, length expressed in terms of width. So this way we'll get rid of our L in our perimeter equation. So replacing L with 264 divided by W, we get 70 equals 2 times 264 divided by W plus 2W. And then this gives us 70 equals 528 divided by W plus 2W. Now we want to get this W out of the denominator, so we're going to multiply everything by W. We distribute that to each term. This gives us 70W equals 528 plus 2W squared. We are going to move the 70W over. And now I'm just going to rewrite this in standard form for a quadratic equation. So that gives us 2W squared minus 70W plus 528 equals 0. So our A is 2, our B is negative 70, and our C is 528. Now we just plug that into the quadratic formula. Okay, so you get negative B, which is going to be positive 70, plus or minus the square root of B squared. B squared will give us 4,900. That's just going to be, over here I'll just write this, negative 70 squared gives us positive 4,900. And then minus 4AC. So minus 4 times 2 is A, and times our C value is times 528. All of this over 2A. So that is 2 times 2. Then when we combine like terms, we get 70 plus or minus the square root this is going to be 4,900 minus, this will combine to 4,224. Right here is 4,224. So this gives us 4,900 minus 4,224, all divided by 4. When we combine this, we get 676. So now we have two solutions. We have 70 plus the square root of 676 divided by 4, and 70 minus the square root of 676 divided by 4. The square root of 676 is 26. So we get 70 plus 26 divided by 4. That's 96 divided by 4, which gives us 24. So that's one possible answer. 70 minus 26 divided by 4 gives us 44 divided by 4, which gives us 11. So recall, these are values for W. We solve for W. So these are two possible W values. You could then plug these into the equation to find the L value. I'm just going to tell you, just for the sake of time, that the two pairs you can possibly have are just the width is 24 and the length is 11. Or you can have the width is 11 and the length is 24. We could plug this into a variety of the expressions presented and determine if that is true. So for example, you need 2L plus 2W to equal 70. So this is a true expression. We could test it out in our calculator or by doing the math out. So 2 times 24 is 48 plus 22 is 70. And likewise, these could be switched. So as you can see, the length and width are really interchangeable in this particular problem.